Hello and welcome to Chapter 1, the beginning, our first introduction. I'm going to go over a few preliminary terms and concepts today dealing with data. First of all, statistics is the science of data. I remember a professor that I had once of mathematics stating to us that he didn't even consider statistics to be a class that should be in the math department. Well, while I disagree with that, one of the points that he made was a fairly good one, that statistics is not just dealing with straight calculation. It is a science. We don't care just about making calculations. Calculator will do a lot of that for you. What we care about is the ability to, as we see in the next one, organize, display, summarize, and ask questions about the data. It's not just about making some calculations, but rather it is about having a conversation with the math. One of my favorite quotes is by Galileo. He said, "Mathematics is the language by which God has written the order of the universe," meaning that mathematics is in the world around us. What statistics allows us to do is that it allows us to organize data and then present it in a coherent manner that can allow us to either make conclusions or make inferences about real situations in the world. Individuals are the objects described by a set of data. So, for example, if I took a survey of my classes, the individuals of that set of data would be the students described by the data. The variable would be a characteristic. So if I took a survey, for example, and I said, "What is your shoe size?" That variable is shoe size, while the individual is the student themselves. Within the variables, you have two types. There's categorical, which it places the individual into one of several groups or categories, and quantitative or numerical. These take numerical values, and sometimes it's easier to think of, do I have between the two, do I have a category or do I have a number that I could take an average of? In comparing the two, categorical data, the individual responses are categorical, they're non-numerical. They're qualitative, not quantitative, and they identify basic differentiating characteristics of the population. Okay, what color is your hair? What color are your eyes? What color is the car you drive? What type of candy do you like? Now, these can still be summarized later numerically, as we'll see in the next lesson, through frequency tables, but ultimately the response to the question being asked is some sort of word-type response that is a category describing a characteristic of the individuals. Numerical are quantitative. Okay, it would make sense to average these values. Numerical, what is your height? Numerical, what is your weight? Numerical, mileage. Numerical, time. Now, within numerical data, we have two types: discrete numerical data and continuous numerical data. Continuous data, it takes on any values in the domain, usually measurements of something. Discrete data is a listable set of values. It counts items. So one of the analogies that I have beneath here with the two images is, okay, so on the left you are measuring a length, whereas on the right with discrete, it's like you're plotting points. So if you were to think about how would these variables, or how would these data, how would they match on a number line? Would I plot them on a number line, or would I measure something with them? Okay, those are the two different types. Now, the reason why we differentiate categorical and numerical and continuous and discrete is that, as we will learn throughout this chapter, the type of data, the type of graph that you use to describe the data depends on the type of data that you have. So, a few other terms. A variable generally takes on many different values. We are often interested in how often a variable takes on each value. So even within a categorical situation, if I have a category and people say, well, my favorite candy is Reese's, it's not just enough to say they said their favorite candy is Reese's, but within the data that I have, how often do the subjects or the individuals of my data make the statement that Reese's is their favorite candy? A distribution tells us what values a variable takes and how often it takes those variables or those values. So in this table here, I have car model and miles per gallon. The variable of interest here is the miles per gallon. Okay, Mercedes-Benz E350 gets 24 miles to the gallon. Mercury Milan, 29 miles to the gallon. Those are the variables of interest. The dot plot or the distribution, the distribution tells us, well, graphically and numerically, how often do these occur? So if you look at the dot plot under where it says 25, which would be right in here, or 28, or 29, or 33 miles per gallon, there are 3 instances in which those have that mileage per gallon. So in other words, we would say that since we're dealing with models of cars, that there are 3 different cars who get, on average, 25 miles to the gallon. There are 2 cars that get, on average, 30 miles to the gallon. So just because you may have a list of data, it still has to be at that data analysis stage of summarized, so it can be dealt with more logically. And some other key terms: a population is the entire collection of individuals or measurements about which information is desired. So if I were to take a survey, for example, of students, I could be looking at a population of a high school. I could be looking at a population of all students in America, all students in Texas. I could be looking at all students in a certain building within a high school, all students within a certain grade, all students with a certain characteristic. The how you define your population changes from data to data, from survey to survey, statistic to statistic. It really depends on what you're doing. Now, a sample is a part of the population. Okay, if I have a class of 3, 4, 500 seniors, do I really want to take 500 surveys, or do I want to randomly select 30 or 40 and then use that to make some sort of inference about the entire population? A good way to think about sample and population: when I get blood tests done, they draw my blood and they look for what is the iron level. They look for what is the iron level of a part of my blood based on the vial that they collected. They don't dump out my entire circulatory system and remove every drop of blood from my body to get the exact answer. If they did that, well, I would die, and I don't particularly want to die. There are too many new Star Trek episodes coming out and movies coming out to want to die. So when I go and get blood work, they make an assumption about the population of all of my blood by taking a sample of it and testing the sample. Now, sometimes if you have a very small population, your sample and the population may be equal. I've got a class of 30 kids. It makes sense to take a survey of all 30 of them. Why? Because otherwise the sample size would be too small. We'll get into that later in another chapter. Okay, within statistics we have 2 types, descriptive and inferential. Descriptive is numerical, graphical, and tabular methods for organizing and summarizing data, whereas inferential is the methods for generalizing from a sample to a population. The way I think of descriptive versus inferential, back in geometry you learned about deductive versus inductive reasoning. Deductive, I'm making a conclusion. Inferential, I'm making a prediction. I'm predicting something, or I'm making an assumption that, it may be disproven, but I think I can make it. That to me is the basis between the two. The descriptive, we're organizing, summarizing the data, and we're getting some conclusions based on just what we see. And then inferential, we're projecting it or we're making a prediction. You can classify data by the number of variables. So remember, the variable is some characteristic of the individuals of the data. Okay, it is some characteristic. So univariate data, it is a single characteristic. If I have data and the only thing I have are their interest in candy or their favorite type of music, one piece of data. But the minute I have two of them, it's bivariate. So what if I also, in my survey, asked them if they were male or female? Well, now I have data that can give me a conclusion about male student preference on candy and female student preference on candy. That is bivariate. Multivariate, more than two characteristics. We won't deal a whole lot with multivariate. It's a bit beyond the scope of this course. But multivariate, so now I could say men of a certain height and their candy choice. Women of a certain height and their candy choice. Okay? But the classification of data, is it one variable, two variables, or three or more variables?